the workpiece and clamp it down to this table so that I can come in here and measure it. And so this is not something that you necessarily need to include in your discussion, but this is what I'm doing right now. I'm going to clamp this down because we don't want this workpiece to move once we start measuring it. If it moves, then we have to start the task all over again. So, and this is just happens to be our setup. This is not necessarily the way they would do it in industry. It's really highly flexible as to how they would do it. Okay, and that's not really an important part of your lesson. Okay, so that's staged. What I'm going to do is go ahead and log on the computer. This is the only seat of software that we have. So this is the only place we're able to run this software. This software is called PCDMIS. PCDMIS. DMIS is Dimensional Metrology Inspection Standard. There's an acronym that stands for something. It's not really all that important for you, but it does come from somewhere. And the software is a product of Hexagon Metrology, which was the company that also. ROMER, little history, ROMER was a standalone company. That's where the name came from, and they were purchased, I don't know how many years ago, by Hexagon Metrology. And so now ROMER is a product of Hexagon Metrology.
Now that software comes as a package with the machine?
No, it's a separate software package that's offered by the same company. There is some software that comes kind of burned into this machine that lets you do some real primitive measuring tasks.
Okay.
PCDMIS is more robust, and it's more of what they use in industry. And the things that we're going to be doing, we might be able to do with the free software that came with the machine, but the stuff I do later in the class, no way could we do that with that software.
Gotcha.
And the software is kind of built on. So the material that you're going to instruct on will be foundational material that we build on when we get into the more advanced stuff.
Right.
So.
Okay.
Okay, so I'm going to go ahead and launch the software now. Okay, so it comes up to this screen, and what we do is just do a file new to create, we create a program in here. That's what we're going to actually create. So we do a file new, and you can type in a part name, and I'll just call this demo part. And if you're in a workplace, you'd put in a revision number and a serial number and some other controlling information. But for us, we'll just put in the name of a part and just click OK. Okay, so this is the basic screen in PCDMIS. Sure. And what we do first is bring in a CAD model of the part we're trying to inspect.
In CAD refers to?
CAD is computer-aided design.
Okay.
So the product was designed in a computer-aided design system, and from there I was able to create this paper blueprint.
Okay.
But I'm also able to now bring in the digital model in here, and that's kind of helpful to be able to see the features and things.
Okay.
Okay. So there's a button right here that says Import from CAD File.
Okay.
And there's the type of file that we are importing on this machine is called a step file. This is the different file formats that we can accept. We're selecting a step file, and this is the file, in this case is the robot ATC bracket. So this is the file that I've loaded in on the hard drive already for this exercise. So I select import, and then I select OK. So this is the part. What I'm going to do over here on the right side of the screen now is change the view orientation. Right now that's looking down on top of it. And I'm going to select this button here to show in an isometric. And then I'm going to select this button to turn on surface edges, and it kind of gives you an outline then.
Okay.
And that's my personal preferences. You know, there's a lot of you don't have to do that. But. Okay, I'm using the roller ball to zoom out. Okay, now we see there's an X, Y, and Z Cartesian coordinate system And this machine uses the XYZ coordinate system. Darn it, I should power up first. I need to power up this machine. Let me see if I wasted my efforts there. No, that's good. Yeah. So now as I move this, you see the XYZ values are updating.
Okay, nice.
Because it's moving in three-dimensional space.
And what would the 0 coordinate be then?
The 0 coordinate right now by default is probably at the base of the machine, so I can't even get to the.
Yeah.
to the
Okay,
origin.
gotcha.
Yeah.
Okay, so by default, the machine will come with a coordinate system that is built into the machine. We can't change it. But my first task is going to be to teach this machine where this part is.
Right.
And that's done by a coordinate system, what they call a coordinate system alignment.
Okay.
I want to align the coordinate system in my CAD file with
Right.
the coordinate system on the physical part. And that's my first step. It's going to be to do an alignment. And so what I'm going to do is come over here and select alignments. And then there are different, depending on the geometry that you have on your part, you can select different options, but we're going to always use this plane line point option. Okay, now this is going to work off the premise that I'm going to go out and measure geometry, and it's going to do some mathematics with that geometry. So it wants me to first select 3 points. That's what the zero says that I've taken 0 measurements, and I need to take a minimum of 3 measurements in order to define a plane. Okay, and I'm going to name that plane something. So I'm going to click up here, and I'm going to call this, so I'm going to measure 3 points on this plane, on the plate. And I'm selecting that because if I look at the X and Y origin, that's what I'm trying to establish is my XY plane. And that's on the bottom of the part. I've got this thing clamped onto the table. So if I measure this table, it's in essence measuring the bottom of the part because they're coplanar. So I'm going to take this now, and there are 3 buttons on this side that I'm going to use. The red button takes the hit. The yellow button accepts, and the white button will reject if I take something wrong. So what I'm going to do is simply touch that like this, down on where I want to hit, and I hit the red button. And that's 1 point that's selected. So I just captured the XYZ coordinates where that tip is.
Right.
And it acknowledges that I measured 1 point, and I'm ready to measure. I still have to do more because I need a total of 3. So I'm going to take a second hit and a third hit. And I just want to scatter these out in a triangle. You don't want 3 points in a straight line because that 3 points could be too close together. I also want to try and keep this tip perpendicular to the surface I'm measuring.
Okay.
And that has something to do with the radius of the ball and things. It's just better if it's perpendicular. So that's my 3rd point. I'll just set that up like so. And I can click next. Next, it wants 2 points to measure along the x-axis here. And I'm going to label this front edge. And I'm going to select a point right here. Notice how I'm perpendicular to the surface. 1 point, and the second point along here. Now what that just did, at first point here, second point here, that created a line pointing that way. And so the order that I've selected those is really important. That means my x-axis is going to be going that way, positive x.
Right.
If I'd selected 1 point here, then the second point here, then my positive x would be going the wrong direction.
Okay.
And I'd end up with a bad coordinate system in the end. And I do have some extra information I'll provide you with some
That'd be
coordinate
great.
system background.
Okay.
Okay, so I'll do a next. And now it needs a single point along this edge over here to determine the coordinate system. So I'm going to tell it that I want to do. Come in here. Sure, that's no problem. And I'll measure this point right here.
Actually, Kevin, you mind just putting it back on the last coordinate you grabbed? I got an out of focus picture.
This guy right here?
The one right before that.
Over here? The second of them?
Thanks. Gotcha.
Alright. Whoa, I just had. I think I just trashed that. I think I had a point held on it and took 155 hits. So let me redo that real quick. I won't take it back. 1 point, 2 points, 3 points. Next. 1 point, 2 points. Next. 1 point. And then I'll do finish. Okay. Now, I should be able to hit this button right here that says set alignment.
Okay.
And it aligned it in with my coordinate system. And now let me see, I should be able to bring this out. And you can
Look at
see
that.
it, put it in that hole, it knows where it is now. Right, so this machine and the part are now synchronized.
Mm-hmm.
Okay. Of course, if we were to remove that part in any way, we'd have to do that procedure all over.
Right. Even if we moved it just over a little bit,
Yep.
right? Same thing.
I'd have to reteach where that part is.
Got it.
Yeah. If I moved it just a fraction, a minute amount.
And that's valuable.
Yeah. Okay, so now we start thinking about our measuring task. And, you know, what I generally do is mark on a piece of paper the features that I've measured. So I've already taken a hit along this edge. I've already taken 2 hits along this edge, and I use this little caret to show that I've got those measured. And then I took 3 hits out here along the paper, along the granite. So if I wanted to, for example, measure this 2 inches, let me see if this 2 inches is right. I've already got this measured as a point. If I were to measure this edge over here as a plane, like maybe 1 point, 2 points, 3 points along that edge, then I would have a flat plane here and a single point, and it'll calculate the shortest distance between that point and the plane.
Mm-hmm.
So why don't I go ahead and do that? So to do that, I come down here to this little symbol right here to measure, and I want to measure a plane. So I tell it the type of geometry that I want to measure. And I can measure points, lines, planes, spheres, cones,
Okay.
cylinders, lots and lots of different types of geometry. So I'm going to measure a plane, and I'm going to call this the right face. And you'll see in a little while why it's handy to write a descriptive name,
Mm-hmm.
because in the end there'll be a whole list of all the items I've measured. I need to say I want a distance between this item and that item, and if they're all just gibberish names, then
Right.
it makes it pretty tough. Okay, so I'm going to come over here, and I'll take 1 point, 2 points, 3 points.
And now the order there, did that
Did
matter?
not matter.
Okay.
Did not matter at all, because I'm creating a plane. So I'll finish that. So that's a plane. You can also see over here it's labeling them. Gives
Okay.
you- It's kind of a little bit cryptic, but it helps a little bit.
Sure.
Helps a little bit. So if I wanted to then measure the hole, let's do the hole next. So I'm going to come in here to measure, and I'll measure this as a cylinder.
Okay.
I want 6 points for the cylinder. When you're measuring a circle, you want to have this kind of tilted over at an edge, at least for your first point. And then for a cylinder, you just want to move it around at different heights. And spread. You want to spread your hits out a little bit. And that was 6 already, I guess. So I'll do a finish. And I'll name this hole. Finish. Okay, so you would basically then go through and measure all the raw geometric elements
Right.
that you needed for your measuring task.
Okay.
And if you forget to measure one, you can always go back later. So you don't have to measure them all and then go to your reporting. But I'm going to move on to the reporting because you get a feel that we would go through and measure lots of different geometry. So what I'm going to do next is create an inspection report of the two features that I've measured.
Okay.
Okay. To do that, we're going to come over here to Insert, Dimension, and let's do the 2-inch dimension first. So that's going to be a distance. Okay. Now this is a nasty looking window. There's tons and tons of stuff, and we're only going to use just a couple of them.
Okay.
Okay, so this allows me to measure the distance between two previously measured geometric elements. Here's a list of the elements that I can choose from. So I'm going to pick the two off this list that I want to get a distance from. One of them was the point. Yeah, you can move that.
Thanks.
Let's see. So one of them was the point 2, which is this point on the left of the part. And the second one was the right face, which is the plane over here on the right. And it's going to measure the shortest distance between those 2 points. Okay. Now, tolerances, plus or minus what? This is plus or minus 0.0. So this is 2 decimal places, so it's plus or minus 0.02, or 03 rather. So I'm going to type in 0.03, 0.03. And the nominal is the dimension that should be. So the print says that should be 2 inches.
Okay.
So that's what I type in for nominal. And we're going to do a 3-dimensional distance check because my plane is a 3-dimensional feature and a hole if I do 3 dimensions. If I had a line over here and a point here, I would need a 2-dimension. It would project it down into the XY plane before it did the distance check. So I don't need to do that now because I have 3-dimensional geometry. And I would just click Create. And it's previewing that for you right here. This is the inspection results. It's showing me the nominal is 2, the plus tolerance is 0.03, the minus is 0.03. The measured value, it measured 1.9945 inches for that dimension. The deviation was minus 0.0055. It's not out of tolerance, so it's showing up as a 0 out of tol. This bar chart is showing that it's a little bit below, but and it shows you how much of your tolerance zone you're using. This is like a bar chart to show you what percent of your tolerance zone is being consumed, basically. How close to the target are you? And I'll print you a hard copy of this here. That'll be put into a hard copy. But I'll do an OK, I'll do a create, and it creates that, it adds it to my report that we'll see here in a minute. Okay, now the only other feature we have is the hole. And to learn about that, we go to Insert, Dimension, Location. Insert dimension location. So we want to know, what do we want to learn about? Well, we want to learn about the hole. So I'm going to select hole. And it opens up a series of windows. So what do I want to know about the hole? I want to know the X and Y coordinate value of the hole. And the nominal value should be, of the print, should be 1. Tolerance should be still 2 no, that's 3 decimal places, so that's plus or minus 0.005. This value should also be 1, because 1 inch up. And I don't need to worry about Z or any of these other things, but I do need to worry about D, which is the diameter. The diameter of this hole should be 0.250. 3 decimal place precision, so that's going to be 0.005. Okay, so I've just done those 2 inspection things. I'm suspicious a little bit of this report. Doesn't look like it saved my data. So let's see what's in the report. I can fix it. Up here, there are 3 buttons, and this center button gives me my report. If you click on the little paintbrush, redraw the report, it gives the report for you here. Now I can see right now that for some reason the data I typed in did not, I must have hit something wrong on this, the whole. The nominal and so forth for the distance is good, but my whole is not correct. So let me go back and fix that. I'll come back in here to my part. And this is the little program that it built. So it's just like a flight data recorder. Everything I've been typing in, it's been saving. So I want to go in and modify that. So if I right mouse click on that, I can select edit, and it opens the window up again.
Right.
And I don't know why it didn't like stuff maybe right there. But anyway, it should have taken that. I don't know why it didn't. So that's more like it. Now if I come back into this screen and I hit the paintbrush to redraw the report, these values are updated now. And that's the end. Then we just print it. Let me go to File. Printing. Printer setup, see what I've got to set up. Yeah, by default it goes to PDF. I'll just send it to this LaserJet. So I'm steering it to the LaserJet, and then just click on the print button, and then it'll print the report. And then when you get to that stage, you do a File, Save. I'll probably do a Save As. And this is going to save the program. I'll just save it on the desktop now. That's it.